Okay, welcome to the final part of your lab. This is where we are going to be looking at data that I'm actually going to give you. I'll show you right now, and you guys are going to be designing an experiment based on that data, and you're going to graph the results. We're going to work a little backwards here, so this is page 10 and 11. We're going to work a little backwards because I'm already giving you the results. I'm going to post this on your Canvas as a PDF file, and it's also here in this mini lecture. So I'm giving you plant growth in soils with different pH values. It looks like I have 1, 2, 3, 4, 5, 6, 7 samples. I have 7 samples of plants, and it looks like one group being analyzed is a pH of the soil. The other one is the average plant growth. This is in centimeters, and I give you those values. Okay, I actually answer one part for you, so I actually want you to do this part first, where you are answering this question. So observe some aspect. I already give you that aspect, plant growth, pH values, and I want you to write the observation or general question. It looks like I'm helping you out there. We are assessing what the optimal soil pH is for plant growth. That's what we are wondering. This observation is going to help us form a hypothesis, which you guys will do yourself in the next section. Remember that a proper hypothesis is based on observations, previous knowledge, in order to form a logical conclusion. It must be in the form of a statement, no questions please, and it must be falsifiable. Can you test it? So I want you to go ahead and form your own hypothesis based on this question that I gave you in the first part. Next, you're going to go ahead and design your experiment. Define your independent variable. Define your dependent. What's your control treatment? What are your standardized variables? Name about 2 for me. Name more if you can. As well, tell me the sample size. So again, just to point this out, you're going to be doing all of these analysis on this page, page 10. Okay, in the next part, you're going to go ahead and graph your results. These are the results right here in this table that I'm giving you. These are the results that were already given. So we're going to go ahead and graph those results. You're going to do a few things yourself. You're going to decide on a range of units and axes. I'll point that out right now on the graph. You're going to plot as a line graph. Lots of students want to give me bar graphs. I want a line graph, please. You're going to label your graph. Don't forget to label the title, the axes, important units that come with that information. And you actually don't have your lab manual, so there's not more info for you. But I already give you the info on the page. So let me show you what I mean. Let me get rid of this. Okay, so on page 11 is where I want you to graph. Recall that your independent variable goes on your x-axis, so that horizontal axis, that's the data for your independent variable, and then the y-axis, the vertical axis, is going to be, you probably guessed it, your dependent variable. So you're not going to write this on your own graph, you're actually going to find the IV, you're going to find the DV and actually plot that on the axis and label it appropriately. Is it the pH, the soil pH? Is it going to be the growth of the plant? Which one's which? That's what I want you to write there. Label your axes. Okay, and then let me actually put this here because a lot of students forget a title. Don't forget to title your graph. You can just title it as the 2 groups that you're analyzing. Okay, here's another thing that students ask me. How do you space your values? Well, it depends on the values that you have. You want to make sure to make your graph as much as you can, the entire page. So I wouldn't want you to just graph something like that and then you make a little graph and then that's it. And that's all you see. What would be better to communicate your results scientifically is to show that kind of result where you have as much space as you can, really reflecting that data. I'm not saying that that's the data that you're going to get, but we want to make sure to use the entire graph. So because of that, we're going to space our values appropriately along the axes. Let me help you out there. You're always going to start there. What that doesn't mean is starting at 0. You don't have to start at 0. You can start at whatever number you want, but we're going to make sure that we have appropriate spacing between values. So let me help you here. pH of soil. pH of soil is 6, 6.2, 6.4, 6.6, 6.8, 7, and 7.2. Those are very small differences between those numbers. We're talking about tenths of differences between some of these numbers. And so we're going to go ahead and really space out those values. What's my lowest number? It looks like it's 6. What's my highest number? Between all of them, doesn't necessarily mean the one at the bottom, but in this chart, yeah, 7.2 is my highest number. So I'm going to go ahead and make sure that in my chart, and I'm kind of helping you out here with your independent variable. To use the entire graph, I'm going to go ahead and start with the lowest number. Notice at this point right here, notice that at this point right here, I don't necessarily have to start at 0, so I'm going to go ahead and define that as 6.0. That's my lowest number, so I'm going to go ahead and start there. Then I want to go ahead and space my values appropriately on that chart. So I'm going to go ahead and you can do this different ways. What I'm going to go ahead and do is that for every 2 squares, I'm going to go ahead and make it. Let me get rid of this just to reflect the data better. I'll go ahead and write IV at the bottom. I'm going to go ahead and write that it increases by that amount. That's 6.2 right there. In fact, what I'm doing is for every box, I am increasing that value by 1/10. That next box would be 6.3, but I'm only writing every 2 boxes, so that's 6.4 to save space. This next box over here, again, 2 boxes between the two. I'm keeping that spacing even between values. I wouldn't write 7.0 for the next one because that makes 0 sense. I need to go ahead and keep that spacing similar. So then the next one would actually be 6.6. 2 more. Keep going. I'm sorry, that's a little hard to read. I'm trying my best to write small here. 7.0, 7, 7.2. 7.2, if you guys actually look again, is my highest value in that chart. So I can actually go ahead and stop there. I want you to do a very similar concept on your y-axis. You're obviously going to have different values. You do not have to start at 0, nor do you have to start on the y-axis with 6.0. It can be a completely different value for the y-axis, but what you do have to do is keep the spacing between values the same. In addition, notice that because I used this spacing, I didn't use this portion of the chart right here, and that's okay if you can't fit it completely in that chart. I want to just make sure that you appropriately space those values. Once all is done and you finish graphing your results, analyze your results for me. And last but not least, you are going to draw a conclusion on your results. Did pH values affect plant growth? Was there a relationship between those two groups? You tell me. That's your lab for What is Science?